Hello everyone, March 21st, Sunday. Just finished cleaning the house. A little bit tired, but let's do this. Oh, we have 6 notifications. What are they? I don't know. I don't know any of these. Counter solution. I don't know any of these. Huh. Anyway, let's do this. Ready? Go. Reordered power of 2. Huh. Okay. Look like an easy question. Man, is it just I don't get there. Is it purely random, the question they choose? I don't understand. Anyway, I thought it's gonna be like harder on the weekends. Anyway, starting with a positive integer, we reorder the integers in any order, including the original order, such that the leading digit is not 0. Okay, return true if and only if we can do this in a way such that the resulting number is a power of 2. That's true, that's false, that's true, that's false, that's true. Okay, so we reorder the digits has, oh, did I say it's an easy question? Probably not. 10 to the 9th. So we're reordering the digits. The leading digits is not 0, okay? So the number of digits, so the length of the digit doesn't change. And we want to see if it's possible to get it to become a power of 2. Okay, what is the characteristic of a power of 2? The power of 2 is, in binary, it's 1 followed by any number of zeros, right? So 1 is a true, which, yeah, 1 is a true. It's followed by 0 zeros. 10 is not true because, I mean, what I'm thinking right now is how can we like change or swap the digits positions, and how does that reflected in the binary code, right? That is the interesting part. So 46 is the thing of interest. But this one is a true. We swap 2 and then it becomes good. So in order to test it, let's just do a equals 64, no 46, and we do binary a, which gives us a 1 0 1 1 0. Okay, so this one gives us 1 0 1 1 0. What's 64? 64 is 1 followed by what? 5 zeros? 6 zeros. 6 zeros. Yeah, 6 zeros. So 64 is 1 followed by 6 zeros. Just by looking at it, I don't see any pattern in this. How do we go from here to here? Well, actually, I have no clue. Like at this moment, I mean, if it's 2 digits, it's all right. Power of 2, right? So, power of 2. 1 is a special case. So we have 2, 4, 8. We're just thinking about the last digits. 6, and oh, okay. So it's only 2, 4, 8, 6, and then we'll repeat. All right, so it's only 4 possibilities, 2, 4, 8, 6. And apparently, if a number doesn't contain any of these numbers, for example, this, it doesn't contain, then it's a false, okay? Now, for a number that does contain, like 24, so we contain 4 or 2, well, let's see. So they just mean that if I have an 8 and we need another value, and we're going to add it together, it becomes, all right, so, power of 2. No idea so far. I was playing with the binary and it doesn't seem to be a viable solution. I mean, how I'm looking back again, just bouncing around some of the ideas. Again, like switching making swaps, how does that manifest in binary code? It's like number minus, so again, we're looking at this again, right? So we're looking at this, what, minus 6 and plus 60. No, it's going to be minus 6 divided by 10 and plus 60. And that won't work if you have, like, say, a 9-digit number and you have anything changing in between. Right, there's an unlimited number of swaps, right? In any order, okay? 10 to the 9th. All right. 10 to the 9th. I don't think we can save that. No, I don't think so. But 10 to the 9th is only what? Wait, what's 2 to the 8? No, 8. 16, right? No, 32. Yeah, it's how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 31. Yeah, 31. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 30 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can do 30, right? 30. 29 is not. 29 is smaller. Okay, so what we're doing is 2 to the 0th. It's actually not that much, right? It's 2 to the 0 to 2 to the 30th. Yeah, it says to 10 to the 9th. So it's 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can't even reach 2 to the 30. So it's 2 to the 29th. So it's 30 numbers. All right, so it's 30 numbers, and we can list them all out. All right, list them all out, and what do we do? Well, we can count the number of digits each one has, and definitely also the digits that's used for each value, but it's not really that useful. So look at this. Got 1, 2, 3, no 4, 5, 6, 7, 8, 9, 0. So except for 4. So each number will have like a unique set of digits that make up this number, right? So we have basically from 2 to the 0 to the 29, so 30 numbers, and we're going to record the number of digits. That probably should be the number of digits will be, yeah, so we're going to have a dictionary. So the number of digits will be the key, right? So the number of digits, that will be the easiest to test, the number of digits, because we'll have to maintain the same number of digits. So then we find the number of digits. So we narrow down to possible options. And then for each one of them, we are going to compare, doing a set comparison, because I think set can do comparison. Like set 1, 2, 3 equals 1, 2, 3 equals set 3, 2, 1. This will give us true. Oh, equal. Yeah, this is true, and if we swap in value, and this will get false. So we can do set comparison, which is the digit. We know what digits got contained in each value, and that can weed out a few more, if possible. And then eventually we will end up with just a few options. And then with these few options, we probably can sort it. Well, we don't have to sort it. Let me see if we need to sort it. Because we can sort it to start with. We don't have to. We don't have to do the set. We can just sort it because it's only 9 digits, right? The maximum is 9 digits, so we can sort it and then do the comparison. And if anyone match, then we have a solution. All right, let's try it. Let's try it. Copy this one. No, when we're doing, yeah, 31st, 21st. We're gonna do this. All right. Take a look at this. Feel like cheating, huh? No, that's not cheating. I think maybe this is how to solve this problem. All right. We're gonna run test cases later. Let's comment out this for now. So we're gonna do all the numbers, all possible. All possibles. No, that's just all powers equals. So we're gonna list them, or do you want to make them directly into the list you want? Let me think. Yeah, we probably can. We're gonna do this. So like we said, we want to use number of digits as the first key, and then within that, we're gonna be a list, right? And then in the list, each value is going to be a sorted array. Yeah, we can do sorted array. Which one will be a sorted array? Okay, so we're gonna say for I in range, so we're gonna from 0 to actually don't need 0. So we have how many? How many is that? 20, 29. Okay, so basically from this to 30, because we cannot do 30. 30 is larger than 10 to the 9th. So for this, we're gonna say power equals 2 to the I, right? And actually, we need to turn it into str because we want to sort it. Hold on, what happens if you sort str? I actually have no idea. So let's say 2 to the, what, 29, right? 2 to 29. If we do that, A is this. What if I say sorted A? Oh, all right. Okay, that's easier. So we're gonna do this, and we're gonna say all powers gonna be len power, and that has to be a default dict. Okay, that has to be a default dict. The collections import default dict, and then there's gonna be default dict. We want a list, which means here we can just say the append sorted power. Okay, so after we've done all this, we're gonna take a look at n. So we're gonna sort n. No, not sort n. So the input we're gonna do on the len n equals hold on, strn equals strn. All right, and then we're gonna do sorted n. It sounds so weird. Sorted n. So I say sorted strn. Then we're gonna say I probably can do it in one line. Let me see. We're gonna say for p in all powers, and the key is len sorted n. No, len. It's the same. strn, or it's the same. So for all p, I want to say p equals sorted n, right? And then we want to return if any of this is possible. Okay? All right, let's now run a test case. First of all, I'll rewrite the test case. So edge case 1, give us true. 10. Actually, we can Let's write a few more. So we know 2 is true, and then we know 3 is false, right? And then if we want wrong 3, let's do a 4 is going to be true. Okay. Now let's say 10 is a false. Let's actually try some. Okay, 16. Right, 16 is true. How about a 61? Right, 61 shall also be true. And 24 is false. I mean, actually, it doesn't really matter. Oh, I know what to test. Oh man, this is dumb. This way of testing is dumb. All right, okay, let's yeah, I know this is a dumb way of testing. I can just loop through all the numbers. It will be way easier to test that way. But we're already here. I'm kind of lazy to get it back. Let's do this. It's gonna be reorder. What's that? N. All right, let's run it. Yeah, we all passed. I think it's right. This is correct. It should be correct. If it's not correct, if we hit any bumps, then we're gonna try a new way of testing. I think it should be right. Pending. Yep, we got it. So maybe this is easy. I mean, it looks easy first, and then kind of daunting looking at this value. But then you realize, no, there are actually not that many values because only 30, right? Only 30 values to compare. And then, once the scale is small, basically you can apply any methods. It doesn't really matter. All right, let's take a look here. Ooh. All right, so, okay. I don't know what to say about this. I guess saying like somebody actually trying to like change the order, like really changing the order. Maybe. All right, let's write a little bit summary here. What should I say? We should say. Well, this problem looks daunting at first, right? Looks daunting at first. But once we realize that the total number of power of 2's is quite limited. Oh, I didn't see somebody have a comment on this. Oh, thank you for commenting. Well, I don't have a Twitch account and I have a YouTube account, so that's why I just started here. Maybe I should. All right. Man, I'm not used to this. I think I break my line of thought. What was I thinking? Number of power is quite limited. Okay, let's keep this. There are only 30 of them. Right, only 30 of them from 2 to the 0s to the 29th. So we can write them out. Oh yeah, I should. All right, so yeah, I'm thinking about it. I should switch to Twitch for a change. Yeah. My thought is broken again. All right, let me get back to it. So we can write them out, and my strategy is to use. I spelled it wrong. Is to use the length of the number as the key, and then group all the power of 2 of the same length, same digit length, right? Same digit length together, and we also do a sort for all the power of 2's such that we can make a simple comparison between the given and to one of the power of 2's. Now this is possible also because the question stipulates that we cannot reduce the length of n when ordering the digits. Now we go overboard. Don't like it. Okay, so what's the runtime? The runtime, so this is basically 01, and power of 2, this is 01. This is, sort is also 01 because we have a defined limit on the power, on the values. So do you dare to say it's 01? Well, it's since all the variables are bounded, this can be considered 01. I just call it 01, but all right, we run at 36 milliseconds, and this gives us a 54% ranking. All right, now let's go back to the question. I think there might be a solution. Yep, there is a solution. Let's take a look. They probably have a brute force at the. Yeah, I know they're gonna have a brute force. I think it's easy. Easy. It's a medium. All right, that's fine. All right, take a look. The heck? Oof. I don't even want to read this. Permute. Oh, it's doable because, I see. Yeah, the same. Because the digits are limited, right? You have the most 9 digits, so you can afford permutation. It's not gonna time you out. Okay. So what do? They do. Oh my goodness. Card 0 is card. Okay, with permutation this, right? And then, that's not card. My goodness, it's candidate. So canned 0 is not okay, and binary. So we turn this into a binary number and count numbers. Okay, yeah, yep. Yeah, this is a one-liner. Counting. Okay, we can check whether two numbers have the same digits. The count, okay. Because since n will have a power of 2 and 9 digits, we can just check whether n has the same digits. So we count. So str count. Oh, so what they're saying is we don't have to sort, we just need to count it. There's actually, why are you sorting then? Why do you sort? Well, I sort because that's the way to compare whether two digits, whether two numbers have the same number of digits. You just said it, same number of digits. You don't have to sort. Yes, same number of digits. Yeah, that's what you want, right? You want, if it match, that means the two numbers have the same number of digits for each digit, which is exactly what counter does. Stupid. I like this one. I probably will write this one. O log n squared, power of 2. Okay. Why there are, okay, I actually don't understand this. Time complexity, I call it 01 just because I'm lazy. I probably shouldn't do that. Yeah, the permutation is factorial. I'm talking about this one. It says it's log n. This doesn't look like log n to me. Are you talking about doing this? And what is your n? The input n. We do. This is O. This is on, right? If we say the number of digits is n, then this is on, right? And then here, this is what, O30, and then we do this, and then for I don't understand why is this log n squared? So the number of candidates of power should be saying what should we say? N in log n is the maximum number. Oh, n is the maximum number, and not the number of digits. Okay, so n is the maximum number. N is this thing. N is this thing. Not the number of digits, but the maximum number. Okay, then this one is O log n. There are log n different candidates. Yes, and each comparison has log n time complexity. Why is that? Why is each comparison has log n time complexity? Because of this. Okay. Yeah. So this is O log n. Yeah, that makes sense. This is O log n. So again, n is this n, and this one is O log n. This one is O log n, and okay, yeah, O log n squared. Okay, that's good. All right, let's see. Okay, Mr. Lee, 215. Counter. So that's the counter solution. Okay. Yeah, that's fine. What else? String sorting. Oh, is that my idea? Group anagram. Convert the input into a string. We saw the string. I did that too. We get the data from the power of 2. Convert them into string. Sort them. As we convert the powers of 2, for each one we compare if the string is equal to that of string based on n. If the 2 equal, then we return. Yeah, that's exactly the same as my idea, but it just okay. They do straightforward. They don't play around with dictionary and stuff. Yeah, it's all the same. All right, let's write the other solution. It should be fairly straightforward. All right, this one will be solution 2. Be based on counter. So we know we can write this in 2 lines. So we say counter n equals, do counter here. So counter. All right, this one will equal to counter strn, right? And then what we want to see is, oh, it's the same solution. I mean, we could do it this way too, but no, I'm just gonna return still any, right? We're gonna say for I in range 30. Wait, they say 31. No, it's 30 because 31 is larger. 31 is larger than 10 to the 9th, so it's actually 30. So for all that, all right, let's do a fancy way. It looks like they do fancy. Is this one faster than 2 to micro optimization is the source of all evil. So we're gonna do this. What are we doing this? We're gonna do str on this, right? Do str on this, and after str, we're gonna do a counter on this. And after we do a counter on this, we're gonna compare this to this, all right? And we're gonna run the test case. I pass. All right, this test case just sore in my eye. I don't like it. I don't like it at all. So let's rewrite it. How can we rewrite? We can rewrite it as. No, let's not do that. I know what you're trying to do. You want to iterate every single one, but that's gonna take a long time to run. So no. This is good enough. This is going to write here. So say this is the official solution using counter. Okay. Actually, let's write a solution 3. I mean, it's the exact same as my original solution, but this one, instead of doing the counter, we're just doing sorted, right? And then we say, it's not counter n, it's going to be sorted n, and then this one, instead of counter, it's going to be sorted. So I think this one shall work as well. Yep, it worked as well. So this is the, this is applying the style of the official solution to our original sorting solution. But sorting is slightly slower than using a counter, because that's n log n. Let's run one of these, and then we're gonna call it a day. Yep, never done this one before. Alright. Always run this just in case. Alright, submit it. Yep, oh, it's faster. How about this? Now I'm curious. I mean, again, this is not very trustworthy, but it is interesting. Let's see. All right. I think it's just overhead of building the. Yeah. It's very straightforward. I kind of complicated. Yeah, right. Overcomplicated. Oh well. Anyway, we're done with this. All right, and that's it. That's it for today. I have someone suggesting to me that I should switch to Twitch. Thank you very much, and thank you for being there. You're the first one. I've been doing this for how long? Like a month, 2 months? You're the first one. Actually made me a little bit nervous, because now I know somebody's actually watching. But yeah, that's a good idea. I should take a look at how I can make this onto Twitch. Yeah, I know Twitch is big for live streaming than YouTube. Kind of, just lazy at the beginning. Don't want to deal with another learning curve, but maybe we should. Anyway, that's it for today. See you guys tomorrow. Adios.